Good evening. Well, I'm afraid Burnham's comet turned out to be something of a disappointment. Quite a number of people wrote in to me to say that they'd managed to see it all right, but it didn't really come up to expectations, and remember, I warned you that it might not. It's become very faint now. Neither is it a very good time at the moment for seeing the planets. Mercury and Venus and Mars are all so badly placed that, to all intents and purposes, they're out of view altogether. And that leaves us with the two giants, Jupiter and Saturn. Jupiter's making quite a brave show, and you can see it in the southern part of the sky late at night. It looks like a very brilliant star, and in fact it's so bright that you can't really mistake it. If you've got a telescope, you'll be able to see its belts and its moons. This is a picture of Jupiter, which also shows that extraordinary feature, the Great Red Spot. Jupiter will be better placed later on this year, and I'll say more about it then, but I'm afraid it is going to be rather inconveniently low for observers in Britain. Following Jupiter round in the sky at the moment is the second giant, Saturn. This is the planet with the rings, a magnificent sight. There's nothing else like it in the sky so far as we know. Saturn looks like a moderately bright, rather yellowish star. I think the best way to find it at the moment is to identify Jupiter and then look over some way towards the east and about the same height above the horizon. And you'll see Saturn there shining quite conspicuously and rather on its own. And of course a small telescope will show the rings quite clearly. Saturn was the outermost of the planets known in ancient times, but since then we found three more: Uranus, Neptune and Pluto. And it's about Uranus, the seventh planet, that I want to talk to you tonight. First of all, here's a drawing of it that I made earlier on this year with my own telescope. Doesn't show very much, I'm afraid. You'll see a lightish part low down the disk towards the right, and you'll also see above the disk a faint star-like point which marks one of the 5 moons or satellites of the planet. But there isn't very much else. And the reason is that Uranus is a long, long way off. Its distance is very much greater than Saturn's. It's something like 1,800 million miles away from the Sun. And that means that it never comes much within 1,600 million miles of us. That means, too, that it takes a long time to complete one journey round the Sun. And I've got a moving model here which will show what's meant. First of all, let's begin with the Sun and the Earth going round it once per year. Transferred on this diagram, of course, to a few seconds. There, near the top of your diagram, is Uranus, which moves very much more slowly and has much further to go. And it takes Uranus 84 of our years to go once round the Sun. So the year there is very different indeed from our own, and the seasons and the calendar must be very different too. Uranus is so far away that it appears faint. But nevertheless, it really is a large globe. It's a true giant, although it's not so big as Jupiter or Saturn. And to show you how much bigger it is than the Earth, I've got a couple of models here. First of all, here's a globe to represent Uranus. And here's a globe to represent the Earth on the same scale. And you can see there's a very considerable difference. Uranus is nearly 30,000 miles across, and you could throw 50 Earths inside it and still leave a certain amount of room to spare. Well, now let's have a look and see where Uranus is in the sky. It's an evening object at the present, and the time to look for it is as soon as the sky is fairly dark after sunset. Let's begin, as we so often do, with the Plough, or the Great Bear, whose 7 stars are so easy to recognize. From them we can find Polaris, the pole star in the north. On the opposite side of the Great Bear, we come to another conspicuous constellation, which is Leo, the lion, and there's one bright star there, Regulus. Not far away from Leo is a much fainter constellation, Cancer, the crab, with a prominent star cluster called Praesepe. At the present moment, Uranus is almost between Regulus and Praesepe, but don't expect to find it a conspicuous naked-eye object. It most certainly is not. In fact, you'll be very lucky to see it without a telescope at all, and I don't think you'll be able to identify it unless you have got optical aid. Because in spite of its great size, it is so far away that it appears only as a faint star, more or less on the limit of naked-eye visibility. It's hardly surprising, then, that it wasn't known in ancient times. In fact, it wasn't discovered until the year 1781, and the story of how it was found is rather interesting. The man responsible was a Hanoverian named William Herschel, who had come to England when still a young man. At that time, he was almost unknown. Later, he became one of the greatest astronomers of all time, and certainly the greatest of his age. He made his own telescopes, and the telescope with which he found Uranus was a reflector of 7 feet focal length. We've got here a picture of an identical reflector constructed by Herschel. This is a picture, incidentally, which was very kindly provided for us by the Science Museum. Herschel wasn't originally an astronomer. He was a musician. He came of a musical family, and for a time he played in the Hanoverian band. Then, when he came over to England, he became organist at the Octagon Chapel in Bath, which incidentally no longer exists. It was pulled down a very long time ago. And about this time, in the early 1770s, he composed some music. Herschel's music is very seldom played now, and I thought you might just like, as a rather historical curio, to hear part of one of his compositions. I don't know quite when it was written, about 1772, I should think. I wonder when that was last played. About 1800, I should think. Herschel discovered Uranus in a rather interesting way. He was busy checking the stars in the constellation of Gemini, the twins, with his 7-foot telescope, and then he noticed a peculiar object which seemed to move from night to night. To show what's meant, we've got a couple of moving diagrams here. The stars, remember, are so far away that their individual movements are not noticeable except over centuries, and so the stars seem to keep virtually the same relative positions. And now look at that little triangle of star-like objects in the center of your picture. The bottom one isn't a star at all. It's a small disk. That, in fact, is the planet Uranus. This is based on a couple of drawings that I made earlier on this year. Now, Herschel noted a formation like that, and on the following night he saw that one of those objects, Uranus, had in fact moved. That meant that it must be relatively near at hand, and of course that followed that it couldn't be a star. So it had to be something else. Actually, Herschel thought it was a comet, and he headed his paper to the Royal Society, An Account of a Comet. But then the orbit or path of this object was worked out, and it became clear that it wasn't a comet at all, but something much more important, a new planet, revolving around the sun at a distance much greater than that of Saturn, which had always been thought to mark the edge of the sun's kingdom. That discovery made Herschel famous and altered his whole life. He became the king's astronomer, not astronomer royal, by the way, he was never that. And he spent a long time at a house in Slough, Observatory House, where he carried on his astronomical research. Observatory House still stands, although I believe there's talk of pulling it down now, and it's certainly deserted. I went there the other day, and we took some photographs of it. On the wall is a plaque commemorating 3 great astronomers: William Herschel himself, his sister Caroline Herschel, who was his devoted assistant for a great many years, and John Herschel, William Herschel's son, who afterwards became a great astronomer in his own right. This is a picture of Observatory House as it looks now. I say it's empty and it's deserted, and it's in rather bad repair, I'm afraid. Here now is a shot of the garden, and you may see there a circular flower bed. Nowadays it's overgrown, but it used to be the site of the greatest telescope in the world, William Herschel's greatest creation, a vast reflector with a focal length of 40 feet. And this is a picture of it as it must have been in the days when it was in use. Nowadays, our modern telescopes are precision instruments moved about by electricity. Nothing of that kind in Herschel's day. He had to use pulleys and ropes. And as you can see, he belonged to an entirely different age. He was a pioneer in every sense of the word. A part of the tube of that great telescope still exists. It's in a shed at the bottom of the garden in Observatory House, and we photographed it the other day, and you can see me there standing by the remains of the great 40-foot telescope. Herschel's main work was in connection with the stars. He wanted to find out how the stars were distributed in space, and he succeeded too, and he really was the father of stellar astronomy. But I suppose he's best remembered nowadays for his discovery of Uranus, which pushed out the boundaries of the solar system. Uranus itself is a most extraordinary world. It's very large, as I've told you, but it's not in the least like the Earth in construction. Instead of having a hard, solid, rocky surface, it's made up of gas, and that gas is intensely cold, at a temperature of something like 300 degrees below 0 Fahrenheit. And although the year is so long, 84 times as long as ours, the day is much shorter than our own, so there must be about 63,000 days in every Uranian year. But if the days on Uranus are peculiar, the seasons are even more so, and that's due to the extraordinary tilt of the axis. We know that the Earth goes round the Sun with its axis tilted at an angle of 23.5 degrees, so as it moves like this. There's the North Pole, there's the South, and here's the axis. It's not straight up. The angle is 23.5 degrees. And that causes our seasons, because in northern summer, the North Pole is tilted towards the Sun, and we get the full force of the Sun's rays. So it's hotter in June and July in the northern hemisphere, even though at that time we are, in fact, at our greatest distance from the Sun. Most of the other planets go round the Sun at very much the same angle. It's Mars and Saturn and Neptune, anyhow. Jupiter goes round at a lesser angle, almost straight up. The tilt's only 3 degrees. But Uranus is different again. Incidentally, there's a delightful old story, I don't know where it came from, that the Earth's axis used to be straight up, and that the hideous crimes of mankind caused it to tilt sideways at an angle of 23.5 degrees. Well, in that case, I hate to think what must have happened on Uranus, because the tilt there is not 23.5 degrees, but 98 degrees, more than a right angle, so that Uranus goes round the Sun like that. Well, you can see that that's going to have a most extraordinary effect upon the seasons. First, much of the northern hemisphere of the planet, and then much of the southern hemisphere, is plunged into darkness for a period which corresponds to 21 of our years. Just imagine it, a 21-year-long night. For the rest of the Uranian year, admittedly, conditions are a bit more normal. Uranus has got 5 satellites. We only have 1 moon. Uranus is rather better served. And here is a picture of Uranus surrounded by its family of moons. Incidentally, Uranus, in the middle of your screen, is very considerably overexposed, and that was quite essential, because all these 5 moons are rather faint objects, and the planet had to be blurred to show them at all. As a matter of fact, these satellites can't be seen except in reasonably large telescopes, and they're among the smaller bodies of the solar system. None of them are as large as our own moon. But just for one moment, let's picture what we could see if it were possible to visit some of these satellites of Uranus, and have a look at Uranus from there. First of all, here's a drawing, by David Hardy, the astronomical artist, and this shows Uranus as it might be from one of its moons. Of course, it is only an artist's impression. It may very well be wrong, we just don't know, but at least it's reasonable, and Uranus might really look like that. Now let's imagine we can go further in still and have a look at Uranus from its closest moon, and this drawing by Patricia Cullen shows us the kind of sight which might meet our eyes. Uranus, then, is an extraordinary place. It's made up of gas, and that gas is mainly hydrogen, so it's intensely cold, and certainly nothing can live there. And of course it will be very many years before men can visit it, or rather its satellites, even if that ever becomes possible. It's a world where the light must be very much less than on Earth, a gloomy place, lifeless, remote, deserted, and slow-moving. But if, in fact, you have got any kind of a telescope, it's worthwhile looking now between Cancer and Leo, and looking for the tiny greenish disk which marks the 7th planet. Good night.